For centuries, naval warfare meant bigger explosions and heavier shells, chemical energy hurling metal at the enemy. But now, we stand at the edge of a new era, the age of electromagnetism. Imagine a weapon that uses no explosives, just raw electricity to launch a projectile at Mach 7. The electromagnetic railgun is that weapon, a leap from gunpowder to pure physics. It promises to transform warship design, tactics, and the very nature of naval combat. No more floating powder kegs, just solid metal slugs and immense power. This is more than an upgrade, it's a revolution, harnessing the universe's fundamental forces. Let's explore how this technology works, the challenges it faces, and what it means for the future of naval warfare. The future is electric, and it's arriving faster than ever. So, what is an electromagnetic railgun? At its core, it's a massive electric circuit. Two parallel rails form a pathway for a colossal surge of electricity. Place a metal projectile between them, and when the current flows, it creates a powerful magnetic field. The Lorentz force, pure electromagnetism, hurls the projectile down the barrel at hypersonic speed. No gunpowder, no moving parts, just electricity and physics. The projectile exits with a sonic boom and a flash of vaporized metal traveling over 7 times the speed of sound. It's a simple, brutal application of nature's laws. The result? A weapon that can strike with devastating force using only kinetic energy. This is the science that could redefine naval firepower. Welcome to the age of the railgun. Compare a railgun to a traditional naval gun, and the differences are dramatic. Old guns rely on explosive propellants, dangerous, bulky, and a constant risk to the ship. Railguns use electricity and solid metal slugs, eliminating the threat of catastrophic magazine explosions. This makes ships safer, lighter, and able to carry more ammunition. Conventional shells are complex, filled with explosives. Railgun projectiles are simple, relying on sheer speed for destruction. Smaller, sleeker, and more aerodynamic railgun rounds mean more shots per ship and easier logistics. Resupplying is safer and simpler, no more handling volatile explosives at sea. The result: longer combat endurance, deeper magazines, and a fundamental shift in naval tactics. Railguns turn warships from limited-shot platforms into arsenals of hypervelocity firepower. The tactical calculus for naval commanders changes completely. This is the dawn of a new kind of naval warfare. The railgun's greatest advantage? Speed. While a standard naval gun fires at Mach 2.5, a railgun launches projectiles at Mach 7, over 2 kilometers per second. At these speeds, the projectile's kinetic energy alone is enough to obliterate targets, no explosives needed. Hypervelocity means less reaction time for enemies and drastically increased range, over 100 nautical miles. Ships can strike from beyond the horizon, safe from most threats. Railguns also make warships safer by removing volatile propellants and explosives. The risk of catastrophic onboard explosions drops dramatically, and there's a cost advantage. Railgun rounds are far cheaper than missiles, allowing for massed, affordable firepower. One ship can deliver hundreds of precise, rapid strikes without breaking the bank. The combination of speed, range, safety, and cost changes everything. The future fleet will be faster, safer, and deadlier. But building a practical railgun is a monumental challenge. The power demands are staggering, millions of amperes in milliseconds, requiring warships to become floating power plants. The rails endure immense forces and heat, leading to rapid wear and the need for breakthrough materials. Early prototypes could only fire a few shots before the rails were destroyed. Engineers are racing to develop barrels that last thousands of rounds. Guidance is another hurdle. Projectiles must survive extreme G-forces and still steer accurately at long range. Miniaturizing and hardening electronics for this environment is a major engineering feat. Every aspect, from power storage to targeting, pushes the limits of science and technology. Overcoming these obstacles is the key to making railguns a reality. The journey is tough, but the payoff could be revolutionary. The world's navies are racing to build a working railgun. The US Navy led the charge, partnering with defense giants to build and test massive prototypes. The BAE Systems railgun at Dahlgren, Virginia fired projectiles with the energy of dozens of speeding cars. China has also entered the race, testing a railgun at sea and signaling a new era of competition. Despite breakthroughs, challenges like barrel life and power integration have slowed progress. In 2021, the The US Navy shifted focus to hypervelocity projectiles for existing guns, but railgun research continues. The knowledge gained is invaluable, and the dream of operational railguns is far from dead. The race is global, and the stakes are high. Whoever masters this technology first could reshape naval power for decades. The pursuit of the railgun is a defining contest of 21st century military innovation. Picture tomorrow's fleet, sleek ships armed with railguns powered by advanced reactors and turbines. Naval battles become long-range duels, fought with hypersonic projectiles over the horizon. One destroyer can support ground troops, intercept missiles, and dominate sea lanes, all from a safe distance. Railguns offer rapid, precise, and affordable firepower for offense and defense. Nations with this tech will hold a decisive edge, reshaping maritime strategy and global power. The high cost of entry means only a few navies may wield this advantage at first. The presence of railgun-equipped fleets will deter adversaries and alter geopolitics. The railgun is more than a weapon. It's a leap into the future, harnessing the universe's raw forces. The journey is long, but the destination is clear, a new era of naval warfare defined by speed, power, and innovation. The thunder of cannons will fade, replaced by the silent flash of electromagnetic might.